Hello friends, this video on Semiconductors Part 25 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 24 before going ahead with Part 25. Now we will talk about some of the parameters related to a transistor. So we will talk about the input because when we talk about the transistor as a circuit, it can be basically divided into two circuits, the input circuit and the output circuit. So the input circuit, if I am talking about the common emitter configuration, the input circuit is the base emitter circuit and the output circuit is the emitter collector circuit. So here we will talk about input resistance of the transistor, output resistance of the transistor and the current amplification factor. These are some of the terms or some of the parameters related to a transistor. Do you know what do you mean by parameters? For example, I can explain it to you in this way. Let us suppose if you want to buy a mobile phone, there are some features which you desire for in your phone, right? Suppose you have not decided which phone to buy. You just go to the shop, you tell the shopkeeper that I want a phone which has the following features. It should have a camera, it should have a camera with this many, you even mention whether you want a 3.2 megapixel camera or whatever it is, right? Similarly, you have other requirements. You want a touch screen, you want an Android, or so you have so there are certain parameters which are related to every product, right? Whether it is a Samsung phone, whether it is an Apple phone, or whether it is a Nokia phone, each of them, each mobile set will have a set of parameters which will be very specific to that particular mobile. Right? For example, the parameters would be like whether it is Android or not, whether it has touch screen or not, whether it is QWERTY or not. So those are the parameters. Similarly, in case of transistor, these are some of the parameters which define a transistor. Okay, if I say I have a transistor of input resistance XYZ. So these parameters basically define a transistor. So let us see what is the input resistance of a transistor. So when I talk about input resistance, I'll concentrate only on the input circuit and on the input characteristics of the transistor. So here if you see, the graph is plotted between current and voltage. So what do you think would be the input resistance of the transistor? Input resistance would be nothing but change in voltage, that is delta VBE by delta IB. So why am I considering change in voltage by change in current? Because here if you say it is not a straight line. Had it been a straight line between voltage and current, I would have directly told that resistance is nothing but voltage by current. But here since it is changing, so at every point your resistance will also change. So we have defined it as the change in voltage by change in current at constant VCE. So this is how we define the input resistance of a transistor. So what is input resistance? It is the ratio of change in base emitter voltage to the resulting change in base current at constant collector emitter voltage. That's because when you change as you change your base emitter voltage, the base current will also keep changing. So this is how we define input resistance. This is a dynamic resistance, as I mentioned before, that since it is changing at every point of time, so it is a dynamic resistance. And that is why we have defined it as the change in a base emitter voltage to the change in base current. The next one is the output current, the output resistance. So how do we define output resistance? In a very similar way, here we will take into consideration the output characteristic graph. So output resistance is nothing but the change in output voltage or change in common emitter voltage, collector emitter voltage to the change in collector current at constant base current. So this is how we define the output resistance. So it is defined as the ratio of change in collector emitter voltage to the change in collector current at a constant base current. The third one is a current amplification factor. So how do we define a current amplification factor? It is the ratio. Whenever we talk about any amplification factor, I am basically trying to compare the output current with the input current in a way, right? So this is defined as the ratio of change in collector current to the change in base current at a constant collector emitter voltage when the transistor is in active state. So right now we are only considering the active state of the transistor. We are not bothered about the cutoff state or the saturation state, right? So in the active state, the ratio of change in collector current to the change in base current, that means we can define it in this way, that let us suppose we denote the amplification factor by beta. We say that the change in collector current to the change in base current at a constant collector emitter voltage. So that is defined as the current amplification factor. Now this beta is often known as small signal current gain. So this is also termed as small signal current gain. Now since here it is a dynamic value again, that is we are dealing with the change in current to the change in base current. So we say that we define this beta, or we define this current amplification factor as the AC gain, AC current gain. Similarly, we define the DC current gain in a circuit as IC divided by IB. Right? So this is how we define the current gain or the current amplification factor in case of a transistor. Well, one important thing which I missed to mention while we were discussing this output resistance. So observe another thing, that the output resistance will increase when your base collector is reverse biased, because whenever a junction is, the biasing or the resistance of a circuit also depends upon the way it is biased. If a circuit is forward biased, that means the current flow in the circuit will be more, therefore the resistance will be less. So the output resistance in a circuit will be more when the base collector junction is reverse biased, whereas the output resistance will be less when the base collector junction is forward biased. So the biasing of the junction, the current flow in the junction and the resistance of that circuit, they are all related to one another, right? So these were some of the parameters which were related to a transistor. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.